Hello everyone, I am Shivam and I welcome you again in my channel. In this video, I will be talking about my PhD interview experiences at different IITs including IIT Roorkee, IIT Guwahati and IIT Hyderabad. And अगर आप लोगों ने previous videos को नहीं देखा है, then you can click on the I button and watch my complete interview playlist. So without wasting any time, let's start this video. Okay, so we will first start with IIT Guwahati interview, which I gave in May 2024 in an online mode. The only department I gave was physics department. So they advised me to be ready with some A4 size papers and a marker to write and show them the answers if they need to see. Okay. So they started with introduction as usual. Then they asked me which topics you are comfortable in. Okay. So I told them quantum mechanics, solid state physics and electromagnetic theory. Then they showed me a Hamiltonian written on a sheet of paper and told me to find the eigenvalues of the Hamiltonian. It was written in basis form, in operator form like this. And then I started solving. I formed a 3x3 matrix out of this Hamiltonian and tried to find the eigenvalues of the Hamiltonian. I calculated on paper. I was a bit slow on paper. So I finally came up with the eigenvalues. One of them was 0 and the other two were plus minus root 2a. Then they told, okay, it's correct. Then the other professor asked that there is a ball at height h from the ground. And he told me to find its velocity when it reaches the ground. It was an easy question from kinematics and equation of motion. So from this formula, I came up with the final velocity when the ball will reach the ground. So he told me, okay, good. The next question was related to this. He told me to replace the ball with a quantum particle. And now he asked me that, can you find the velocity of the particle now? What will change? So I told them that we cannot find the velocity of the quantum particle as before due to the uncertainty principle. Then he asked me, what different thing are you doing that it cannot be applied to this particle? So I was a little bit confused in the starting. Then he gave some hints. So I told him that due to uncertainty principle, we cannot certainly find the position and velocity of a same particle simultaneously. So this is the statement from Heisenberg uncertainty principle. In the previous question, for the classical particle, we fix the position of the particle, initial position of the particle, that is height h, y equal to h, and also the initial velocity of the particle u, which was 0. And we can do that for a classical particle. We can certainly tell that this is the velocity of a particle and this is the position of the particle, and we can predict the motion. But in the quantum case, the position y and the velocity of the particle cannot be simultaneously fixed due to uncertainty principle. So the velocity, the final velocity, we cannot certainly tell what will be the final velocity using that same equation of motion. We'll have to trigger Schrodinger equation and all to find the trajectory and the future evolution of the particle. So I answered like this and he was satisfied. Then the next question he asked was from graph, and he told me to draw a graph of ln x. Okay, so it was easy. I drew the graph. तो इसके बाद उन्होंने बोला कि draw the graph of x ln x. So I tried drawing like this. What will be the value of y at x equal to 0, then at x equal to 1, x tending to infinity, and I came up with this graph. So this was the last question they asked in IIT Guwahati Physics Department interview. And now let's move to IIT Roorkee interview, which I gave in December 2024. It was also a mid-year cycle admission. So the first question they asked was the introduction as usual. Okay. After the introduction, they asked me about the project in detail. As I mentioned the project, whatever I did in my master's, in the introduction part, they asked me the details of my project. So I explained them about my project, which was on triboelectric nanogenerators, and then they went into electronics part of my project work. But I could not answer much of the part. They asked about resistor, capacitor, circuits and all. Then they moved to the Maxwell equations. They asked me to write the Maxwell equations in vacuum and medium. So I wrote the equation in SI unit. As I was writing, I wrote the second equation, and then they told, okay, it's fine. They knew that I knew. So the next question they asked was, what do you understand by the permittivity of the medium? So I explained them that it is a measure of how much a material can be polarized on the application of an external electric field, or how the charges inside the material responding to the applied electric field. It is a measure of that. We can also relate it to the capacitance of the material. Then they move to dielectrics and capacitors. Okay, so then they told me to consider a dielectric and let us apply an electric field in one particular direction. Then what will happen? So I explained them by drawing the diagram of the dielectric, and this is a dielectric medium with some dielectric constant epsilon r. Okay, if I apply an electric field in the right direction, x direction, what will happen? There will be some charge separation, okay, inside the material. There will be some dipole formation inside the material, and then due to that separation there will be a net dipole moment inside the material, and then the material will be polarized and there will be a net polarization inside the material. There will be some displacement vector also, which is equals to epsilon naught epsilon r times the applied electric field. And these charges are bound charges, as this is a dielectric material, so these charges cannot move in the material, but they are bound to the material. So the next question they asked was, how will you interpret this if a material has high epsilon r or low epsilon r? So I told them that higher dielectric constant means higher d or higher polarization. So higher will be the response of the material to the applied electric field. So following up on that, they asked me to explain a little bit more and asked me about the complex nature of the dielectric constant. So I explained them that dielectric constant is a complex number, complex quantity, which has some real part and some imaginary part. And this real part tells us about the storage of the charges or the reflection and transmission of electric field or light, anything. And the imaginary part tells us about the loss mechanism inside the material, the loss in the form of heat or the dissipation of energies or the absorption by the material, that we can understand by this imaginary part of the dielectric constant. And also I told them that a refractive index is related to the dielectric constant of the material as under root of epsilon r, only if the material is non-magnetic, that is mu r is equals to 1. So the refractive index is also a complex quantity. So then they asked how the dielectric constant is complex and how and why I am explaining the heat dissipation through the imaginary part. I tried answering this question, but was not able to completely answer the question accurately. And at last they asked me about any particular research interest for the PhD. So I told them that semiconductor technology and nanomaterials, condensed matter physics and all. So this was the last question they asked, and the interview ended like this. So that's how my interview went at Physics Department, IIT Roorkee. And now let's move to IIT Hyderabad Physics Department interview. Okay, so IIT Hyderabad Physics Department interview was also in an online mode like IIT Guwahati. क्योंकि ऑनलाइन इंटरव्यू में ज़्यादा नर्वसनेस नहीं आता है, so all my online interviews went very well. Like the IIT Guwahati, IIT Hyderabad interviews was kind of good for me. In IIT Hyderabad, they started with the introduction as usual. Then they told me to explain my MSc project in detail and what experiment I performed. Then I told them that I did some characterization of the material using XRD, X-ray diffraction, Fourier transform, infrared spectroscopy, scanning electron microscopy, SEM, and then some IV measurements. So then one of the professors asked me that what is FTIR and how does it work, all the mechanism of FTIR. So I explained them that what is FTIR, it is a spectroscopic technique. Full form I told them that Fourier transform, infrared spectroscopy. Okay, and then I explained them the mechanism and working only through voice. I did not write anything on paper. They just wanted to know how much I know and how much I can explain verbally and orally. So I explained them how FTIR works. Then there was follow-up questions which I don't remember. Then they asked me questions on vibrational and rotational levels, the spacing between these energies and all. So I explained them these also, that there are electronics level first, then in between electronics level and there are vibrational levels, and then there are rotational levels. So the energy of the rotational levels is less than the energy between the vibrational level, and which is also less than the energy between electronic levels. So the electronic levels has the highest energy gaps, then comes the vibrational, then comes the rotational. Then they moved to photocurrents measurements and p-n junction, as I told them that I did some IV measurement. So they asked, how do you measure photocurrent if you shine light on a p-n junction? So I answered this question with the explanation of photovoltaic effect. If you shine light on a p-n junction, then in which if we shine light on p-n junction, then the electron hole pair will be generated at the junction, and these electron holes will move opposite to each other, creating a current. And if we connect the two terminals of the p-n junction with some wire or load or ammeter, we can measure the photocurrent. And if there is no load, like a resistor or something, if we directly connect short circuited, then that current is called the short circuit current. And then there is some open circuit voltage, VOC, and all these things I explained them. Then they ask me, what will happen to the current density that you are measuring if you keep on increasing the intensity of light that you are shining on the p-n junction? So will it be infinitely increasing, or will it stop increasing at some particular time? So I told them that current will not increase infinitely if we keep on increasing the intensity of light, and it will saturate after a particular point. And the reason for that is, first, photocurrent increases linearly with the intensity of light, then it saturates because the carriers start to build up, and the recombination rate increases. So if we increase the intensity of light, the electron hole pair recombines faster, and then there is no separation of the electron hole pairs, and we cannot get the increased current. So I answered this question, and then they asked me a last question, which was also on graph. They told me to draw some graph, but I don't remember what was that function. But finally I drew it, and it was correct, I guess. And this is how my PhD interview at IIT Hyderabad for physics department ended. So these were my interview experiences at different IITs for PhD physics. And as you can see that these interviews were not that much hard and also not that much long. And as two of them was online, so in online interviews, they will take the interview at max for 15 to 20 minutes. So in my case also, they took 15 to 20 minutes at max, and they asked simple 6 to 7 questions. And one more point is that online interviews are much more comfortable and easy to give, as you are not so nervous as compared to the offline interviews. In offline interviews, there are 3 to 4 professors in front of you, and you get a bit nervous, but in online interview, you are calm, composed, sitting at your place, and can think and give the answer more comfortably. So my suggestion would be, never skip any online interview. You will get selected. 90% chances are that you will get selected in an online interview. Okay, so this was all about the PhD interview experiences at different IITs, and I will be uploading some more videos on interview preparation which I gave last year, which includes some IISERs and the NISER. So see you in the next video. Tab tak ke liye, bye bye.